Hello folks, how are you doing today? I'm back with another episode of tutorials for machine learning. Today we're going to talk about hyperparameter optimization, mostly regarding the best two methods called random search and grid search methods. Let's get right onto it, shall we? Alrighty there. So, hyperparameters. So, did you guys ever think, whenever you started learning about machine learning that, you know, um, you have done almost everything, you have run the model and everything, but still it does not, the accuracy or the performance is still lagging behind somewhere, and you feel like you have to do something there? Yeah, here's the thing, what you need to do. You actually need to do hyperparameter tuning there, right? So now let's you might have heard these two words, parameters and hyperparameters, whenever you're studying or doing something related to the machine learning. Let's know more about that. So they actually are specific points that help us fine-tune the model for a specific task and better performance. So it's just like, you're making some changes or on your bike, for example, to get overall better performance, mileage, you want it to go faster, kind of that way. Um, so there are a couple of things here. The first one is the parameters. They are actually the internal points of the model that are estimated automatically during training of the data. Okay, so basically what they are is they're estimated from the data automatically. They're a part of model that learns automatically from historical data. You actually do not need to do anything. But but there's a big but here. In order for them to learn automatically, you will actually need another point here. That's the hyperparameters. They are points that are set up manually and are used in processes that help estimate the model parameters. So as you see, exactly, that's right. Parameters, they are dependent on hyperparameters. Then hyperparameters, they must be manually tuned. And then, you know, this thing is actually done by trial and error. There is no specific documentation or something that tells us that, do this and you'll get best performance. No. Okay, so now we've sorted out what hyperparameters and parameters are. Let's go right ahead. Okay, so this is a small example of how I'd like you to know what both of them are. So on in here, there are hyperparameters. For example, you might have learned about neural networks while you're studying or in your school. So hyperparameters are this. So when you change the layers, number of neurons, the learning rate, these are hyperparameters. When you make changes to this, the changes reflect on the parameters. The parameters are weights and weight optimization. That's what you want to do, right? And when you optimize your weights, your score gets optimized, right? So making changes to hyperparameters makes changes in the parameters, and which indirectly changes your score, right? That's how, these are just three scenarios where we have made changes in here, the number of neurons in the learning rate, and you get different scores here. Yeah, next one. So there are the most popular methods for hyperparameter optimization are these two. One is your grid search method and one is your random search method. What are those? Why are they popular? Let's get right onto it. So basically, grid search and random search methods are, grid search methods, they both have their own advantages and disadvantages, but it actually depends on how you want to use them. What are your requirements? Grid search is used mostly when you have, basic understanding of parameters range. For example, if you take, k nearest neighbors, and if you have such a particular problem there, and you know that the value of k would be between 2 to 10 approximately, that's where you use grid search. It takes less time and it checks every position on the grid. So that's why it's called grid search. While on the other hand, the random search method um, is when you actually do not have any idea. You do not know, for example, the value of k in the k nearest neighbors, right? That's where you give a wider range there, and then this method actually tests each and every one of those values, all those combinations, and then it gives you the results. So as a result, it takes a very long time to run. So which one to use? My suggestion would be first try grid search, because it takes lesser time, and it's better in terms of the time, and then you go for the random search. Okay. So next thing is some other important facts would be, so as we said before, bigger your data set, the more time it takes to run, and so it would be nice to reduce a little bit of time, right? Even in the random search. So I have one of the methods here is there's actually, let me show you here. Yeah. So when you go to grid search here, there's actually a parameter called n underscore jobs. So this is basically the number of cores that's in your computer, okay? Number of jobs that run in parallel. So if you put this parameter to -1, that means that all of the cores of your system would run in parallel, and this thing would be a lot faster. Okay, this is actually just one of the methods. There are several of the methods. You can check them out on the internet. They're pretty good. Also, while choosing the hyperparameter, you guys must have thought, this guy's mentioning hyperparameter, but what are they? How do we choose them? Well, actually, if you look in the API documentation of the algorithms like KNN, it's actually provided there. Let me show you. Here you go. So this is the documentation for K-neighbor classifier class. Um, Here, as you can see, that there are parameters. There's n neighbors, which is the most important one, and weights. Depending on, there's also others, but depending on your needs, you can, put them, use them. Okay. All right. And next is the examples of parameters and hyperparameters. Okay. So as I said, KNN. For KNN, the hyperparameter is K. This is actually just one scenario, okay, and in which in case affects the centroid and the training data. So this hyperparameter affects this model parameter, which in place affects the accuracy of the algorithm. So this is on one under SVM support vector machine. There are three hyperparameters: sigma, kernel, and C. They also affect the support vector weights. Then there's decision tree, the hyperparameters depth of tree, and the parameters which they affect are splitting point. So these are just examples. So basically, hyperparameters are some points or parameters, and you changing them will bring changes in parameters, and with changes in model parameters, the model accuracy also changes. Well, obviously, it improves, but you never know, eh? All right, guys, that's the end of this end of your tutorial. I hope you guys enjoyed it.